Triplets. Здравейте, разбойници! Това е четвъртото издание на четвъртото ни събитие на българска Java потребителска група. Днес ще си говорим за Quarkus. Много сме доволни, имаме хубав гост. Сега ще минем и на английски, защото госта ни не разбира български и не знае какво говорим зад гърба му. So, hello, ladies and gentlemen. This is our fourth event, and Roberto is here. Is going to talk about Quarkus, and Ivan is going to introduce him.
Yeah, thanks, Michel. So, unfortunately, Roberto doesn't speak Bulgarian yet.
Sorry about that.
I'll have to teach him next time. Yeah,
yes,
Roberto,
please.
welcome. I'm really glad to have you here. My big friend Roberto from JBoss, Red Hat, and one of the senior developers of the Small Ripe collection of libraries, leader of the Coimbra project, and as such, he is Portuguese, and his home nation is playing football in maybe an hour and a half against Hungary in their first initial opening game in Euro 2020, which is held in 2021. So, Roberto, how do you feel about your...
Yeah, that's confusing. Yeah, I mean, of course, there is like such a high hope for the national team, especially considering that they won the last Euro Cup. So they're like a couple of new players, also some old players. So there's a lot of people that are putting their high hopes on Ronaldo, but I mean Ronaldo is also already has like 4 years on top from the last cup. So let's see what happens. I mean they're very good nations also playing, and I mean it's football, right? So. Sometimes you get teams winning that you're not completely aware, or at least you were not expecting them to win. That's the beauty of the game, right? So it is unfortunate that the Euro Cup needs to happen in this situation that we live right now, but hopefully people can get a little bit distracted from that. So I since we're here, let me just give like a quick word for the Danish player that fell on the field. So he's actually, yeah, I follow his career for some time. So hopefully it seems he's doing okay. So we hope that none of those situations happen again. And other than that, I hope that everyone enjoys the Euro Cup and everything goes okay.
Roberto, I know that you're the leader of the Coimbra project, and you organized the JNation conference. Can you tell us more about the conference?
Yeah, that's correct. So thank you so much for asking. So like any other jug, like we started small and we begin increasing our numbers until we got to a position where we thought that we could start our own conference, and we did just that. So we had our first edition in 2018, and well, the idea was to just keep doing it as a physical event, right? And even like last year, we were expecting to beat or to reach 1,000 attendees, which was probably a very great number for us. Unfortunately, due to the situation, we had to cancel it, but we moved it to, like a lot of other conferences, to online, to these online events, in the hopes that we can come up with the conference to the physical event again. So maybe we can do it as a physical event next year. So for now, we're just doing it online so we can keep the name going and people can watch something. And we that's kind of like a good occasion. So for people who are listening to us here today, the conference is actually going to happen tomorrow. So if you want to have a look into that, you can go and check generation.pt. That's the website. So the conference is completely free. We're gonna have like 4 tracks from 9:30 our time to like 9. So in Bulgarian time, I guess it will be like 11:30 in the morning to 11 in the evening. So there are like plenty of slots that you can choose to look from. And we cover all kinds of topics, since Java, of course, both backend and front end stuff, JavaScript, TypeScript, server side, cloud, machine learning, AI. So, and some soft skill stuff as well. So I guess that there's going to be a lot of sessions that you can choose from, and you can probably find something that you'll be interested in. So even if you cannot stay for the full duration, you can go in and see something that you enjoy.
Are you going to stream it via the virtual jug again?
So yes, so we announced it on the Virtual Jug, and we're gonna stream it over there as well. I mean, just go to our website really, so it's probably easier. And
Okay.
but we can probably have the links to the Virtual Jug as well, even though we announced it on the Virtual Jug with a redirect to our own links. But um, the link's just gonna be a YouTube stream that you can follow, and you can just switch between one and the other, and it's completely free, so you don't really require a sign up. So whenever you want to go, you just go, and whenever you have to leave, you have to leave. And that's okay. We do follow the same approach as the Virtual Jug, where we have our own Slack channel, and people can join that Slack so they can talk with each other more directly between the attendees, and comment and share whatever they want in real time. But I mean, it's not complete. It's not mandatory. So if you just want to listen the stream or be on the stream, you can do it just fine. So feel free to attend. It's completely free. And if there is if for some reason you can't, or if there are like multiple topics that you want to see at the same time and you can't, well, no worries, because after the conference is done, then give us a couple of weeks and we'll publish all the sessions one by one, so you can look them up later and see them up later completely free as well.
Okay, great. Good luck tomorrow.
Oh, wonderful. Thanks.
And yeah, whoever wants, I repeat, jnation.pt, PT from Portugal. Okay, and without further ado, let's go to our main topic for this evening or this afternoon, and it's Quarkus. And let me quickly switch to Roberto's screen. Now, Roberto, your screen is on, and we are muting. We are disappearing ourselves, and the stage or the screen is totally yours. Good luck.
Okay, wonderful.
And by the way, to everybody, whichever platform you are using, you can ask your questions to Roberto. This is an interactive code jam session. So you can ask your questions to Roberto, and we'll be happy to relay them to him at some point. So yeah, be active. This session is for you.
Yeah, thank you. So yeah, feel free to interrupt me anytime. Of course, we can take some questions in the end. But I'm completely fine if I have to interrupt whatever I'm doing to answer whatever question comes up. So feel free to interrupt me anytime.
Okay. Good luck.
Okay, so this is Quarkus World Tour for the Bulgarian Jug. It's been quite an interesting ride. We started these like a few weeks ago, and I've been doing them regularly in some places. The interesting thing is that I was already giving this session in Portuguese, in Spanish, and in English. Unfortunately, I cannot do it in Bulgarian, so I have to learn about that. But I've done this session for Bolivia, for Brazil, for Madrid. I'm gonna do that for Barcelona on Thursday. So I mean, I've been in a couple of places virtually. Unfortunately, I cannot do that physically, but maybe we can do like a Quarkus World Tour next year in person. That will be more interesting, right? So thank you so much for hosting us. You, of course, are the real crowd and the real people that want to learn about what Quarkus is, and hopefully I'll be able to provide you some knowledge and some tips and a lot of things that Quarkus is and Quarkus isn't. And maybe if you're already a Quarkus user, you can learn a couple of things. And if you're not, maybe you get curious enough to go and try it. Anyway, no matter what, you'll have my contact and you can reach me out anytime you want with any of your Quarkus questions, either on the session or afterwards. So that's completely fine. No, for the presentation itself, this is not really a heavy slide presentation, so I only have here a couple of slides to introduce the topics, and I want, of course, give a couple of overview on how Quarkus works internally, because that's a part of the secret. Well, it's not a secret, but it is what makes Quarkus the technology that it is today. And once you understand how Quarkus works internally, then things will make more sense. So either on how we can claim certain things, and maybe because you might be experiencing some particular issue which may relate it on how Quarkus handles stuff. So I think it's always useful to understand how a technology works internally. But in the case of Quarkus, I think this is even more important, especially to understand the exact claims that that we do with Quarkus, right? So the idea is just try to talk a little bit about how Quarkus works. I'll do like a quick demo first, and then we'll just move to just demos, and I can type some code for you. And if you're looking for some particular thing, just let me know, and I may try to adjust it in real time. I usually have a lot of stuff prepared, more than I have time to show. So I might be able to show you something completely out of the box if you're looking for something in particular. So that's myself. I'm already the presenter, so I'm not gonna do anything out of this. So let's move straight away to Quarkus. So yes, Quarkus. Maybe you have heard about this, maybe you haven't. So usually when you want to learn about a new technology, the right place to go is that technology website. So for our own website, what we say is, so Quarkus, we call it supersonic subatomic Java, and we like to think Quarkus as a Kubernetes native stack that's able to either run on the OpenJDK or on graalvm, where you can use wherever library that you like, but we usually ship with the best of breed Java libraries and standards. So Quarkus was launched like a couple of years ago. I think it was like 2 years ago in March or something. Now we used to joke about something which is, yes, Quarkus was launched like 2 years ago, but most likely all of you already have like 5, 6, 7, even more years of experience with Quarkus than you realize, right? And the reason for this is because we use a lot of the standards and the de facto standard libraries that all Java developers already use on their traditional projects, in the sense that when you start coding a Quarkus application, you don't have to learn any new APIs. We're already using the regular APIs that are out there, so that will keep your learning curve really small, and you should be able to pretty much code a small Quarkus application really easy and really quick. Now, one of the things that we try to do, so yes, there are already a lot of servers and other frameworks and technologies that mix some of those breeds and libraries around. But the missing ingredient that we think that makes the difference is try to introduce what we call developer joy. And developer joy is try to get out of the way everything that is going to block you when you want to do your own code, right? So one of the things that we're pretty much proud of is the development mode, right? So if you haven't heard about development mode, so development mode is a mode in Quarkus that allow you to type your own code and have instant reload times. So you don't have to go through the pain of, okay, I made a change, now I have to go and restart my server, or I have to recompile and redeploy, and then you wait maybe like 5, 6, 10 seconds. I mean, it may not seem much, right? But it's still for us developers, we are like super lazy and we don't like to wait. It's usually time for you to move to another tab, go and read some news, and when you notice there's already like 2 or 3 minutes past, so we wasted some time over there, and that cycle repeats a few times a day, maybe even more, maybe a few dozens of times a day. So it's always wasted time. No, that's one aspect, right? Another aspect that we tried to give you was, yes, we tried to improve those integrations with those libraries in the sense that they make the life easier for you. So simple things like, well, if you're like an Hibernate user, or a JPA user, you know that you require a persistent XML file. So that's something that's mandatory because yes, the technology says that you have to use it. But then you notice that you go to that file and that file is mostly empty or has like a couple of XSD declarations and that's it. So we like to question ourselves, wait, I mean, why do we have to keep adding this file, which is empty most of the time? So it's just like a burden. And if you don't add it, like things don't work properly, right? So you have to add it. And so one of the things that we did was to just make that file mandatory, even if both Hibernate or JPA requires that. So we try to walk some extra miles and try to remove and go against some of the specs and some of the APIs requirements, just to make, not because we believe those things are right or wrong, it's because we just think that they're going to make the developer's life more easy than just having over there. So those like a couple of quick examples. No, I'm gonna do just a really quick demo. So I'm not sure if we have. I'm not completely sure about our audience over here today. So maybe all of you are already Quarkus users, and if that's the case, then I'm not gonna show you something new, or most likely not gonna be something new. And I mean that's great because all of you are already using Quarkus. But if we have someone in the audience that's already using Quarkus, then I think you're gonna enjoy this pretty much. So let me go here really quick uh, to to my terminal. So let me increase this a little bit more. And I have here like a quick project that I'm going to show you. So this is a Quarkus project. So it has a couple of microservices, nothing really groundbreaking. And so I have here these what I call number API. And for now, I'm just going to launch this command called Quarkus dev. And this is launching Quarkus in development mode. So I'm using Maven, so no worries. So Quarkus also supports Gradle if you prefer to use Gradle. It's mostly fine. And now you see, okay, Quarkus launches, so it's like super fast in like a couple of seconds. Okay, you might be saying, yeah, I mean, you probably have like a very small project, and yes, that's the case. But even in bigger projects, you can also see like how Quarkus starts. And in here in this number API, I have like a couple of REST endpoints, or actually just one. So it's this number resource. Let me increase this a little bit. And what you have over here is, so that's the REST portion, which is like extracted here on this interface. So it has a path, a get, and a path generate. So I'm not going to go over the API right now. What you have to trust me, this is just a REST endpoint. And what we're doing over here is we're just generating random number for maybe creating like a book, and this is actually part to another microservice. So the other microservice that we have is going to call this one to generate the SVN of the book. But right now we're not going to do that. We're just going to call this service directly. So we have like a couple of configurations with the generation prefix. So we're just going to ignore that for now. And if I go here to my browser again, so let me open here a new tab. So let me increase this like that. And if we move to localhost 8081, that's where I'm running this Quarkus server. So now you'll see there's like a couple of things over here. I'm going to go through all of that in a sec. But now I'm just going to say, hey, numbers / generate. And I have here a BK. So that's like the prefix that's being generated. And then you'll see that when I hit refresh, the number changes. So it's a little bit slow. And the reason why it's slow is because, well, I have here a sleep. But now I'm going to come over here and I'm just going to say return hello Bulgarian jug. And I probably was not completely prepared because I probably should have just written this in Bulgarian. So sorry about that. And now I come over here and I do a refresh, and now you'll see hello Bulgarian jug, right? And you probably noticed that I haven't really do anything when I was basically refreshing or changing my code. I just came here to my IDE. I just typed some code. I can have like a couple of exclamation points. Then I switch back to the browser, hit refresh, and bam, here's my change straight away. So I haven't done any redeploys, I haven't done any compiles, I haven't stopped or start my server. So Quarkus was just able to figure out that I made changes to my source code. So Quarkus made the reload on itself, and as you can see, it was like super fast, even though this is like a small service, but it works just as fine into some more complicated servers or more complicated applications. And so this for us is like one of the things that we call developer joy, right? So you can come over here, you can pretty much do your own code. So if you want to add a new endpoint, yes, that's fine. So let's come over here and we can say our response. Instead of doing response, we can say string and say like new endpoint. So that's not written properly. So you can actually see that this actually also works with some more complex changes. Actually works with any change, right? But I just want to show you a more complex change where you actually have to change an interface and implement a method. So now you say, hey, new endpoint, and of course you need to add a couple of annotations over here. So you'll say this is the get. And now you say the path for these will be, well, new endpoint. And so we're not done yet. So let's just say I'll return hello from new endpoint, right? Oops. And now if I come over here and I think we did new endpoint, right? So new endpoint, if I made everything correct, now you get hello from new endpoint, right? And you see it's I changed the URL. I hit enter, and that's like blazingly fast, right? You didn't really notice any delay. And as you can also see, I also made like, I mean, it was not really a really big complex change, but it was like, okay, change an interface, implemented the method, so it not only works on changing method bodies. I mean, it works on wherever change you're doing, right? And we're really happy about this. We think that it's really great. So a lot of people are happy about this feature that we provide on Quarkus. So this is one of the things that we enjoy the most. Okay, so let me go back to the slides, if I can find them. Over here. Do we have any questions so far? Hello? I'm still here.
Oops, sorry, I was muted. No questions yet. Go on.
Hello? Just to make sure that, okay, sorry. I see Ivan over there.
Yeah, can you hear me?
I can.
Okay, no questions yet.
Okay, sorry. I was just making sure that that my connection was still okay, and maybe I clicked crash and then I was just speaking to someone else. And
we have one question just arrived from Stefan.
Yep.
How this will work with Java modules?
Yeah, so for now we don't have any modules or Jigsaw support. For the sole reason that we don't think that we need them, especially because when I will go into the next couple of slides and explain how Quarkus works internally, we don't see how modules can benefit from us. So we never really try that. But the live reload feature, basically what it does is we just reload everything, right? Or it just basically what we do is we just detect wherever was changes on the source level and then recompile and then reload them back on the server. The thing is, because the way that we do things internally is like super fast, you actually never notice what we're doing under the covers, right? So I hope that clears up the question.
Hopefully. So yeah, you can go on.
Yeah. So no. Let me go a little bit into the theoretical part. So a lot of you are probably experienced on how regular runtimes work, right? And so what usually happens is we do our code, we write our code, we do a package of that code, can either be with Maven or Gradle, doesn't really matter. And then from that point forward, that's when we're actually going to run our code, right? So we pick up that jar file, we either deploy it on the server, or maybe it's like an Uber jar, and you just run the jar directly. But only on that point, a couple of operations are going to happen, right? So usually the runtimes are going to start to inspect the jar file, check for I don't know, like REST endpoints or beans that needs to be created, right? It needs to like load configuration, load a bunch of metadata, right? So there's a lot of operation that happens when you actually run your application, either by an Uber jar, or if you're deploying that as a WAR file or even a jar file in an application server. And only after all these operations are performed, that's where your application is ready to start. And that usually requires several seconds, and depending, of course, on the application size, for the application to be ready, right? Now, what we do on Quarkus is we try to shift things a little bit, and what we do is, instead of doing most of the work in runtime, we try to do as much as we can during the build, right? So let me give you a quick example. Now, think about Hibernate. So I'm not sure if all of you are familiar with Hibernate, but usually, well, Hibernate is one of the most popular technologies around, so I'm guessing that a lot of you are aware of that. But this is valid, of course, for pretty much everything. Now, when Hibernate starts, right, and you have your entities that are connected to the database, so Hibernate starts up, like scans the class path to find the entity. So those are the classes that are annotated with that entity. And then it has to read them, it has to create this meta model in memory, right? And then it's probably mostly ready to start. Now, what we do is, instead of doing that during runtime, we do that on compile time, so or when we call it build time. So what we do is we search for those things, we create the meta model that Hibernate reads, directly on compile, we create all the meta model, we serialize it, so when the application starts, it only has to read that serialized data that already has everything prepared, request for Hibernate to start. Now, this of course has like a couple of advantages. So one is all of that work that usually happens when you start the application does not happen anymore. So it means that the application is going to run faster. It's going to start faster. Second is, so when you're reading these metadata or when you're loading all of this stuff, right? After Hibernate creates all of this meta model in memory, that code that created that meta model or read stuff from the class path or read like configuration files is not needed anymore. So it's usually like what we call like one-shot code, where it just uses to like load stuff, and then after that is loaded, you don't need it anymore. So what we do is we do this step, what we call dead code elimination, which is we remove the code that's not required for your application to start, right? Because I mean, if you already loaded what Hibernate needs, we don't need the code that loads what Hibernate needs anymore, right? So that means that your application is going to consume less memory. So what we're seeing over here is you have, by us following this approach, you're going to have applications that are going to consume less memory, and you're going to have applications that are going to have quicker startup times. Now, the example I gave with Hibernate is one, but now you can multiply this with all the other frameworks, all the other libraries that do like very similar things. And even worse, one of the things that usually happens as well is all of these libraries, all of these frameworks, most of the times have their own class path scanning. So meaning that, okay, Hibernate is going to do like this class path scanning, and then maybe Camel comes in and does another class path scanning. So now you have multiple libraries like doing the scan like multiple times to the class path to find stuff, right? So it's not really unusual for you to find the application on startup doing like 20, 30, or 40 scans to the class path. Of course, like scanning the class paths, which is something on the file system, is going to take time. So one of the other things we do is we create a dictionary of the class path on build time. So all of other libraries can consult that dictionary on build. So there is only a single class path scan happening. So of course we're going to save a lot of time in that situation. Now you might be asking as well for yourself is, okay, so if you're moving all the work from runtime to build time, does that mean that the compile is going to be slower? Yeah, well, yes, but only for a couple of seconds. So the numbers that we've been seeing compared to other frameworks and runtimes, they're not really relevant, because we optimize some other stuff as well, that the compile times that you get are not really relevant compared to a regular compile where you don't perform these operations, right? Now, for you the key takes on what we're trying to explain is okay, so we move it as much as possible to the build phase, right? Now, because we don't need some of the code that's required on runtime, so we try to minimize the runtime dependencies as well, and that's why we say that we don't think we require modules, because we already do, well, we don't have like any module system, but we try aggressively remove what you don't need on runtime. And we try to maximize what we call the dead code elimination. So the example that I gave with Hibernate is one thing, but you can think about it something like, okay, I want to load an XML file, then I have, and usually what you do is you load the XML file, then you have like that XML file representation in memory, and then you operate on that. You usually don't require that code to load the XML file anymore, so we remove that. So we try to do that as much as we can. And yes, we introduced these metadata contracts that Quarkus then uses to push all the information required for when Quarkus is starting up on runtime, is able to load wherever it needs without requiring to do really slow calls to the file system to load stuff, right? Now, this translates into a couple of things. So here are a couple of examples. So if you're looking like a traditional cloud native stack, and as you know, the JVM is like memory hungry, and so even like a very small service can go to more than 100 meg. So what we're seeing is if you have like a simple REST endpoint that can usually take like 130 meg, something that's done on Quarkus the exact same way usually is like half the size, right? And the reason for that to happen is for what I told you so far, right? If we remove some of the code that's not required, then there are less things that the JVM has to load. So it means that it doesn't require so much memory. So I think that's pretty simple to understand. Now, one of the things that I haven't talked so far, and we're going to have a look into that with more detail in the next couple of slides, is about the native image and GraalVM. So GraalVM is a new virtual machine. Well, not exactly new; it's already a couple of years old, but is a virtual machine coming from Oracle Labs, and so it has a lot of cool stuff in it. It's like a polyglot VM. It's able to run Java, JavaScript, Ruby, Python, but it also has this really cool feature called the native image, where it's actually able to pick up your Java application and resolve everything around it to create like this closer world view on that application and run it as a completely separate binary file without requiring the JVM. So that's the key take on that. Now, of course, there's a lot of complicated stuff involved into that operation. I'm going to give a couple of overview on that, but the idea that I want to show right now with that native image is if you compile Quarkus in a Quarkus application native image, you're going to see even better memory results, right? So in this particular case, with a traditional REST endpoint, you'll see like a tenth of the size in memory for that particular application. So on the side, you'll see the same comparison when you're having like a CRUD application. So a CRUD is like create, run, and update and delete. So an application that's doing like database operations. And yes, of course, the memory on the JVM mode is a little bit higher for Quarkus as well, but still less than a traditional stack. But if you look into native mode, it's going to be again a tenth of the size. Now, if you're looking into response times and startup time, now you'll see that we have really good times compared to other things. So it's not really, I mean, it's really usual to see regular runtimes to take maybe like 10, 12, 15, 20, depend on the application. You probably remember and you've probably seen applications that take like a couple of minutes to start. And with Quarkus, we see startup times that taking usually 5 times less. So while one application can take like 10 seconds, we should take like 2. And with native mode, we're talking even on millisecond level on startup time. And I think, again, that it's really easy to claim that this is completely true with the explanation that I gave you on how the Quarkus architecture works, right? So you can probably relate, yes, we're loading less classes, so we use less memory, so there are less operations that you have to do on runtime. So of course that also means that we're gonna start up faster. So I think that that's really easy to understand. Now, one of the big motivations why we did this is for cloud, right? So if you think before the cloud, but even after the cloud doesn't really matter, but before people are starting to move things to the cloud, you usually buy like this really expensive rack. But when you think about doing that purchase, you usually bought in with some specific resources, so a certain amount of RAM, a certain amount of CPU, and they were there forever, right? So you weren't that concerned on how many resources your application is going to use, especially considering that in most occasions you will buy extra resources in case your application will scale. So if we're using a little bit more memory, it was not really a big deal. Now, for cloud, the landscape changed dramatically, right? Because pretty much all cloud providers, they charge you by CPU that you use and for memory that you use, right? So now is relevant any little bit that you can save. Now to give you an example is, think about you have like a really high scale application and you have to run 100 nodes of something, and that 100 nodes take like 10 seconds to start. So there's like 1,000 seconds of cloud cost that you have to pay right there. Now, what about if you have the same but only taking 2 seconds? So you're cutting like a fifth of the cost they're gonna have to pay for the startup time, right? And the same applies to memory. So if you're able to save on your cloud infrastructure by using Quarkus, then I think like it's a great thing. Before moving to Red Hat, I was working as a consultant, and we did exactly just that. So I was working with this company where it was kind of cool because they were doing all this software as a service, so they're doing everything on the cloud. And when we started to do like Quarkus applications, we were able to actually see a difference compared to the regular stacks that we were using in terms of memory consumption, in terms of CPU consumption, and of course, in the end, in terms of cost of the cloud provider that we were paying to maintain the same services, right? So maybe if you have this just like a single node application, that's not going to be that relevant for you, even though, of course, we have a lot of other offerings that's going to be interesting. But I think that in this particular situation, that's where Quarkus really, really starts to shine compared to everything else. Now, so I'm gonna skip this. I mean, I think I pretty much already explained a lot of that. Now, talking a little bit about GraalVM, and this also relates with a lot of other optimizations that we have done on Quarkus is, so if you remember what I told you earlier, so GraalVM does this native image where it has this closed world assumption on what's going on the application. But there are limitations, right? So for instance, things like dynamic class loading, that's not supported by GraalVM. Even things like reflection, that's supported, but it's limited, right? And for you to give an example why that's the case is, well, if GraalVM will support reflection as a whole, that will mean that it couldn't do any optimizations about removing things that are not required, right? It will still mean, because like a reflection call, if you're aware, well, you just like have like a string and you reference like a class or a field or a method name like that, but usually it's only checks at runtime. So if GraalVM will have to support reflection as a whole, it will have to still keep all the JVM, all the class path that you have, so it will know how to satisfy that reflection call. Now, the way that GraalVM supports reflection is you have to manually tell GraalVM what are the reflections call that you're going to perform. So okay, so GraalVM sees, okay, there's going to be a reflection call over here, so I'm going to have to include, I'm going to have to keep this class or this package or whatever, so the reflection can go successfully. And I mean, there are a couple of other things that are not supported, like Security Manager. Maybe that's not really relevant because Security Manager is going to be deprecated. But again, there are these limitations. And so one of the other things that we do with Quarkus is we try as much as we can to integrate those libraries that you all enjoy and love, like Hibernate, the REST Easy, Camel, MicroProfile, Jaeger, Docker, and so on and so forth. Even Spring, we even have Spring APIs. In a way that, as you know, there's a lot of reflection involved, so we write these extensions around them to try to remove all of these problematic pieces of code that require reflection, that require the dynamic class loading, so they are able to be run and compiled in native and you don't have to do that yourself. Even when I'm saying that reflection calls, you have to supply that manually. Well, you don't have to do it on your own. So we automatically scan everything that's required, and we generate the configuration for GraalVM, so you're able to run, or you're able to build it natively with pretty much zero config, and we try to make it like an easy operation for you, the user. Now, yes. So let me move forward. So yes, I really try to explain that we try to give you like a full stack framework with a lot of stuff that's already up there. So these are a couple of things that we support. And to make it completely clear, Quarkus supports everything on the Java ecosystem, right? So feel free to use everything that you want. Now, there are things that we support directly, because that means that they are written in a way that are going to work in native mode. So what I'm trying to say over here is all of the things that we support ourselves, we guarantee they're going to work on GraalVM and in native mode. Now, if you go and use something out there on the Java ecosystem that we don't support, yes, that's definitely going to work on JVM mode, because I mean, JVM is JVM, so that's fine. But maybe that library has something that requires some particular change to work on native. So that's the only difference from the things that we support for things that we don't support. Is the native image support, and of course some of the enhancements that we do on top of these libraries. So this brings us to the next topic, which is the logic that we write to make the library compatible with what we described before, right? So the build time processing and the native mapping and whatever. So it requires what we call a Quarkus extension. So we have the Quarkus Hibernate extension, or the Quarkus Camel extensions, or the Quarkus Vertex extensions, and so on and so forth. I mean, a Quarkus extension is not really hard to write. We already have a lot of extensions provided by the community. You can make it your own. You don't really have to. If you're lucky enough that your library is already in a state that is able to be supported by GraalVM and the native image, most likely not, and not an one. But there are still going to be some cases that you might want to write an extension, right? So if you think, again, in that particular case, where you're doing a lot of operations on runtime, if you're using library as is, then those operations are still going to happen over there. So most likely you want to write the Quarkus extensions to split the work and call some of that runtime code during build, and then feed in the Quarkus metadata to the other part of your library, so it can benefit on a faster startup time. Well, maybe you heard that Quarkus is a lot of stuff. So maybe some people heard that just a native compiler, or it's just for Kubernetes, or just for small applications. Well, I think we believe that Quarkus is way, way more than this. Now, the native compiler and the native image is completely optional. So you can use it where you think it makes sense. But what we try to say is that it's much easier for you to compile to native if you use Quarkus. Well, maybe think is Quarkus just for REST applications. Well, actually, you can build Quarkus to any sort of Java applications. It can be like microservice. You can do it for a monolith. It can be REST applications. It can be messaging applications. We have a bunch of Kafka and reactive messaging support, and a lot of reactive support. It can be used to do jobs, bots, even command line interfaces. So the command line interface is really a cool use case that we haven't thought about it when we first started Quarkus. So for instance, in my case, I really hate Bash script. I can probably write a piece of code in Java in like half an hour. It's going to take me like a week to do in Bash script. But the problem with batch script is, well, it is portable, right? In Java, I mean, even though it's portable, it requires like the other person to have the JVM and has a lot of other stuff involved. Well, I can now write my Java application, then build it natively, and then I just distribute the native executable, so I don't require the JVM on them, and I can just run it as like any native executable that will do. So that's like a very cool use case. Now, another use case that's really interesting is, like we mentioned, since Quarkus has like this really startup time and this really low memory footprint, so Quarkus is really suited to embeddable applications when you want to run things with don't have many resources like a Raspberry Pi or even some other ARM devices, right? So we've seen a couple of users as well trying to do that. So even myself, so I have some IoT stuff going at home, so I try to control the lights at my place with a lot of things that I do. So I wrote a couple of Quarkus applications that I run on a Raspberry Pi, and that's really great. So it starts really quick on the Pi, and as you know, the Pi doesn't really have that many resources, so it's really perfect for that use case. So Quarkus is a copy of Spring. Well, I mean, Quarkus is a completely full stack, right? So it's really tailored for doing containers and Kubernetes. Of course, there's going to be very similarities about Spring. Now, for Spring users that are out there, I mean, don't get me wrong, I love Spring, and I know that Spring is also doing a lot of stuff related with native image, even though I believe that Quarkus is still ahead in that particular space. But for Spring users, we do provide the own Spring APIs for you to use on Quarkus, right? Because we do things in build time, we can pretty much pick up the Spring annotations and do whatever the Spring annotation behavior requires to have the same behavior as a Spring application, right? So if you want to write the Spring REST application using the Spring annotations, that's perfectly possible in Quarkus, and I'm gonna try to show you a sample with that. So I think that's pretty much what I wanted to show you or tell you about the architecture before moving to some of the demos.
Okay, Roberto, can you hear me?
Before going into there, I just want to give a couple of other overviews. Now, Quarkus itself, it's a completely open source project, even though it's sponsored by Red Hat. We have a lot of commuters, so we have more than 400 commuters right now. The project is on GitHub, so feel free to go over there and search for that. So we have a Zulip chat where all the Quarkus developers are around. So if you have any question, you can go and usually get answers like in the minute. Also mailing list. So there's a bunch of things around the community that you can expect. And I mean, so we have this community version of Quarkus. Of course, there is also the product version of Quarkus that's supported by Red Hat, like we do for like with other products. But of course, the community version is really far ahead. You don't have to worry about the support. So if you want to have like pay support, you can, but it's not really relevant because the community version is the fixes are like super quick, and if you actually not having any answers on that, you feel free to go and submit your own pull request to fix whatever bug you found. And we usually do releases every couple of weeks, so you're not going to be stuck for a long time. Okay, so I think that was pretty much everything that I want to show you on the slide side. So now everything else on the presentation we're just going to reserve for coding and for demos. Before I start that, is there any question from the audience that anyone likes to ask or want me to answer?
Yes, there is, but I don't think you can hear me. Can you hear me, Roberto?
Yeah, I can.
Okay, cool. Yeah, so there's a question from Buddha, who is a great fan of Hibernate Reactive.
Okay.
And yeah, he has a very specific question actually about it.
Okay.
So what he asks is, when you need to create a production ready project, a lot of times you need some database versioning,
Yeah.
Currently, Hibernate plus Hibernate Reactive has issues with migration libraries like Liquibase. That's one of the two most
Yeah.
used, Liquibase and
Liquidways and
Flyway.
Flyway. Yes.
Yeah. So, is this a direction you are working in, or is this a problem of Liquibase?
Well, I mean, of course, this is a problem with Flyway and Wikiways, right? So the issue, and I mean that is on our radar, right? And that was brought to us a couple of times already. Now the issue with that is both Flyway and Wikibase have to provide a reactive way to update the database, right? The problem is that right now they're doing it as a blocking, right? So that's not going to help a reactive application. So we already have, I think they're already hoping a couple of issues and have a chat with them. And it's not only about us. I mean, every other framework that wants to support reactive and wants to have migration using Flyway or Liquibase has that same situation. So same as Spring or Liberty or Wildfly or whatever. So the problem here is not on Quarkus itself, it's just the library, either Flyway or Liquibase. So we unfortunately at the time we don't have resources to go over there and implement the reactive pieces that are required on both Flyway and Liquibase for them to support reactive migrations. But I think that's something that those communities have to figure out themselves and implement them on their libraries. So then people that want to use reactive full stack, then they can also benefit from them.
Okay, thank you for your answer. No more questions yet.
Okay. Okay, so moving on. So I showed here that quick demo, but now let me start from the very basics. Now you're a new user. You want to start a project really quick. So one of the things you can go do is you come to this website called Quarkus.io, and this actually has allows you to bootstrap a Quarkus application, right? So you can come over here and you can set up uh, a group ID. So I just say io.quarkus, and we can say artifact ID, or you can say Quarkus like world tour, and now you can say Bulgarian jug for the artifact ID. So these both support Maven and Gradle. Yes, Gradle is on preview, but works just fine. I'm just like a really old guy and prefer Maven. And then here you have all the extensions that Quarkus supports. Again, remember, you can use other libraries that are not over here, but these are the ones that we guarantee they're going to work with native and have all the optimizations that I discussed previously. So yes, you can come over here and say, hey, I want a REST easy application with Jackson. And yes, we have that user that was using Hibernate. So right now I'm just picking up the regular libraries, but let's just say that we want reactive. So yes, we can come over here and we have the reactive flavor of things. So let's see where it is. Here we go. So we can keep resistor reactive and Hibernate reactive and reactive Jackson. And yes, now I have I can start my reactive application. So let's just generate that, and this downloads like a zip file. So if I go to my terminal, so I'm still running this version of Quarkus. Let's just stop that. So this goes to downloads, and this goes to Bulgarian jug. So here is my Quarkus application that I just downloaded from that website. Of course, you can come here to the IDE. You can just open it up directly. So let's do that really quick. So that went to downloads, Bulgarian jug. Let's open that. And pretty much everything that you require is already out here for you to start coding, right? So it takes like a couple of, this is on the IDE, so it takes like a couple of seconds to import. And I guess that I haven't downloaded the latest Quarkus version yet, so it has to download a couple of things. Yes, but now you have here like a reactive REST endpoint and a couple of resources and a couple of images for Docker. So you have like a couple of templates over here, and that's okay. So the idea here is you go to code.quarkus.io, you pick up whatever you want, download it, and then you can start coding straight away. If you want to add more extension, that's fine. There is like on the Maven plugin or the Redis plugin, you can just add a few more, or you just, of course, go to the POM file and add the dependencies yourself. But let me move to the other project that I have. So let me actually, let me go just do a rollback on this. And I want to show you the code a little bit better. Of course, this is already done by me, so it has a couple of other changes that you usually you won't get when you do the download. So one of the things that I did was to I've extracted all the REST endpoints annotations to an interface, so it becomes a little more clean. So you can split it up, and then you can focus more on the business code over here. But that's just like a design detail, not really related with Quarkus. Now, on the organization side of things, one of the things that I want to show you here is if I go here to the Java where I have my sources and I do a find and I search for Quarkus, well, there's nothing. You cannot find any Quarkus, right? So if you go here to the imports, you'll see, well, there are imports on microprofile, there are imports on Javax, and that's it, right? Because we're using microprofile for some APIs, we're using Jakarta E for some other APIs. We could probably, or we can actually do the REST endpoints also using Vertex. So what I'm trying to say over here is maybe this is a Quarkus application, but you cannot find any Quarkus imports over here, right? So all of these is already known to you. So you can start your own Quarkus application right now with probably the knowledge that you already have. Now, there are some places you're going to find some Quarkus specific things, and one of that is the configuration side. So you'll see there is this application.properties where we set all the configurations that are required for the application. And you can see there are like a bunch of stuff over here. So I'm not going to go into details because that's not the point. But the idea with the Quarkus configuration is we try to centralize and make consistent all the configurations into a single place, right? So if you, for instance, if you want to set up some Hibernate configuration, you have like Quarkus.hibernate something. And if you want to set up some Kafka stuff, you have Quarkus.kafka, whatever. So the idea over here is all the configurations are consistent, and you can change them over here. And of course, if you change the configuration, they're also going to hot reload as you will do with the code. Okay, so let me start up the server once again, as I'll be doing it like with Quarkus Dev. And here we go. So if I go to the website again, so I want to show you a couple of extra things that I haven't shown before. So it's running on 8081. So of course, on the root folder, there's nothing deployed, or there's no REST endpoint. So of course, you get the 404, but Quarkus tells you here, hey, this is available. So maybe that's the one that you want to call, and it will just list over here whatever the endpoints are already there. You can see the beans, observers, so things about what's happening for Arc, which is the CLI implementation that we use. We also have like health endpoints, and those are particularly interesting for Kubernetes, right? We have this dev console. So on the dev console itself, so this dev console is really dynamic, right? Because each extension contributes things for the dev console, right? So as you can see, we have configurations. You have this config editor where you can change configurations straight away from here. So you have Open API. So now you can see that there is like this Swagger UI where you have all the documentation for the endpoint that you place it around, and you can even execute and get the results from here. Sorry. And yes, there are some other extensions that we provide, and even as you can see over here, you even have like a direct link to the particular Quarkus guide for that extension, right? So you can check the documentation and see any interesting stuff that this particular extension may do or may not do. Now, the last thing I want to show you in this particular place, well, not the last thing, but right now for doing all this overview on the project itself, is the POM file. And these, I mean, for Gradle, it's going to be very similar, but just in Gradle format. So, sorry, that's not the right one. That's the one that I want to show. So this now is where you're going to find some Quarkus specific things. So now you see that one of the dependencies we have is a Quarkus bomb. And some of the dependencies that we use are Quarkus specific. So now you'll see that instead of us using Quarkus or using like org REST easy, you use Quarkus REST easy. Or instead of using small open API, you use Quarkus small open API. And again, this is part of that extension explanation that I gave, which what we do is we create an extension that wraps a particular library to put the Quarkus magic on top, and then of course are the ones that you have to use. Now, you can probably use the REST easy directly over here. That should probably fine, but then you will lose all the benefits that I explained earlier. So that's why we recommend that if there is a Quarkus extension for the library that you want to use, well, just use that one, because that's the one that that's going to have all the Quarkus magic, that's going to have like a better developer experience for you. Now, one additional thing that you get on Quarkus is testing. So if you look into, so this is like a test class, and you'll see that you have these annotated with Quarkus test. So when you annotate like a JUnit, so this is like a JUnit, we're using like JUnit 5 plain unit tests. And when you annotate Quarkus test, what happens is this test class is going to bootstrap all the Quarkus runtime, and then run, of course, the test with Quarkus, and then it's going to trash Quarkus, and that's it. So again, it's pretty useful to test Quarkus stuff directly from either IDE, of course, having your test is going to run with your build, but executing Quarkus as well. Going into testing, we have a very cool feature that we added since Quarkus 2. So Quarkus 2 is not final yet. We are on the release candidate period, but we hope to have a final version soon. And we have, so I actually have to do a couple of, I have to do a couple of changes over here, and it's not because of the feature, it's just because I haven't really configured this properly. So let me run, so I want to run Quarkus port on 8080 for now. So it's 8081. And this is because Quarkus run tests on 8081. So now you'll see that when I run Quarkus dev, you'll see there is like here on the bottom of my screen say like test pause, press R to resume. So what is this? So let me hit R. And now what's happening is, so Quarkus is actually running the tests that I have on my application. So I have Quarkus running and it's actually running the test at the same time. So maybe what's going to happen next is, well, I'm going to come over here. Let me change, I'm going to change, like do like a really quick change over here. So I'm changing the assert mode and I come over here. Now you notice that I only held tab to show the terminal and Quarkus run the same test. While before you actually run, I have like 4 tests. So I have this one over here and I have like a three more over there. But now Quarkus was able, so let me show over here. So actually I think that we cleared that up. But basically Quarkus say, hey, running 0 of 1. So what happens is Quarkus detected changes on the test and run the test that was affecting that test, right? So what I'm trying to say over here is that not only you have a dev reload, while you can actually have the test running all the time, and then when you do some change, only the affected tests are going to be executed, so you get also like really quick feedback. So you might be saying, well, okay, that was easy because you changed that test, so Quarkus was able to detect that you only changed that one. Well, let's try to do like something a little bit trickier. So I'm going to come to the resource, and I'm going to say, again, return hello. Doesn't really matter. Oh, it has to be a response, sorry. So it's going to be hello inside of this. And if I come over here, now you'll see that Quarkus was able to detect that the source file that's actually the REST endpoint affected the test and executed that particular test, but it didn't touch the other ones. So only one test is failing and only one test was run. If you look into the other tests, they don't have any, so we're only testing like direct API calls. They're not really calling any REST endpoints. So Quarkus is really smart in this particular case. So of course, if you come over here and let's just put things as they were, and then you come over here, yeah, let's Quarkus will just run everything, and everything is passing, and then we're happy, right? So that's a really neat trick and cool trick, I believe. Okay, so one of the other things that I told you is, well, Quarkus is a native stack for Kubernetes.
There's a question.
So I actually have a Kubernetes cluster running on my box. So I usually don't remember this command. So this command is not really that difficult. It's just that my memory is really bad. So I'm just going to copy it from here. And let's say mvn verify. So okay, so the command I'm doing over here is just verify, and then I'm passing like a couple of command lines saying Quarkus container image build and Kubernetes deploy. So the only thing that I'm doing is telling Quarkus to build the Docker image and to do a deploy of that Docker image to Kubernetes. Let me just run that. So it shouldn't take too much time. Well, it's done like in 12 seconds. And if I run Docker PS, so you'll see there's like a Kubernetes pod over here running. If I do Docker images, you'll see there was like a Docker image that was generated like just a few seconds ago, so 22 seconds. So that was the Docker image that Quarkus generated. And of course, I can do kubectl log and that's the pod. And now you see that Quarkus is running over here on my Kubernetes cluster. So of course, if I go to localhost 8080, well, actually I think it's running on 80 for Kubernetes. Okay, so now you have the same thing. That's great. I can come and I can just say numbers.generate, and I have here my number generation. Well, I want to change the code, right? So probably if I'm running Kubernetes, I have to redeploy the code and do a bunch of things. Well, not so much. I can do Quarkus remote dev, and what Quarkus remote dev is going to do is actually going to connect to the Kubernetes that's running, where Quarkus is running, and now I have the exact same experience that you have locally with that mode, but directly into Kubernetes with your Docker image, right? Which is probably a little bit crazy when you think about it, but let's see if that actually works. So let's say again, return hello Bulgarian jug. And here we go. Now you have your Kubernetes cluster with the Docker image of Quarkus, and now you even have like a development mode for that one. So it is a little bit slower than the local one, of course, because all the changes have to be transferred by HTTP, of course. Now, if you even have a look into the logs, you'll see, yes, sending the jars, sending some stuff, and this is done by HTTP. But the interesting thing for this use case is, let's just say that you have like some additional services on Kubernetes, like databases, Kafka servers, or whatever, and you want to debug stuff, you want to develop stuff, so you can do this. And you may even want to have like your coworkers like contributing stuff to the same Quarkus instances, and it's going to be like a really cool thing to do. Of course, this is not. We don't recommend to use this in production, but I think it's a really valuable and really cool tool for you to use in development or QA in those environments, right? Okay, so let's just kill that one. And well, I can just let me just show you something else. So as you can see, when I show you the properties file before, I don't really have like a bunch of things over here. So you'll see there are like a couple of Quarkus configurations for Docker and for Kubernetes, and this is just to say, hey, this is just to override Docker Hub, so it just deploys the image on my local Docker repository, and of course it's insecure, and I want to use this latest tag. So there is not a bunch of things out here. So everything else is just inferred by Quarkus. So there is not. We try to come up with all these sensible defaults. So to try to minimize all the configuration, and what you actually get in the end is, if you go and see when you generate that command, you'll have like a Kubernetes YAML file which have all the deployments for Kubernetes, and that's where we actually do the deployment. So you don't even have to do deployment for Quarkus. You can just use the Quarkus to generate the Kubernetes deployment, and you're done. And of course, you can create your own and have Quarkus use whatever you want, or you can just influence how Quarkus is going to generate that one for you. Now, let me do something tricky over here. So now I'm going to do this one. So what I'm going to do over here is I'm just doing the build as native for the Quarkus for this Quarkus application. So this requires GraalVM. I have that installed, and now you see there's a lot of other operation happening. The native image build requires a little bit more time because basically there's a lot of operations involved, right? So the native image compiler is trying to get rid of stuff, is trying to resolve all the stuff. So the operation is really similar on what you will do like 20 years ago if you're trying to compile a C application or C program, if you are from those days. So it's quite interesting that after 20 years, we're now doing the same as we were doing like 20 years ago. So that's why I'm saying that it does have a lot of stuff involved. But again, as you've seen, I don't have like a bunch of configurations. I just put like package dash native, and that's like a profile that Quarkus provides to you. And the idea with the native is not something that you want to compile often, right? Especially because it takes so much time. We tried as much as we could to have the same experience that you will have running a Quarkus application in JVM mode and running the Quarkus application in native mode. So in the end, you should be more than fine to develop your application in a VM mode, and then just when you have to deploy it, then you just build it in native and you're done. So for instance, you can use your continuous integration to do this for you, so you don't have to worry. Now the compile is done, so it took like a couple of minutes. Now I'm going to do something that you should never do, right? So if I do an else target, you'll see now you have a number API runner. It's like 57 meg. So you should never do this, please. Never do this at home or at homework or at school or wherever. So I'm going to do a cat. So now you'll see that this is a completely binary application. I think that proves that. Usually sometimes machines doesn't like you to do this, so they go a little bit crazy. And now, how do you run any binary application? Well, with a dot slash target, okay, number API runner, and boom. Now, it's already started. Now you see that Quarkus actually start in, let me actually try to increase this a little bit if you don't able to see it. So it's right over here. So in 18 milliseconds, right? So it's really, really crazy. So let me do that again. Maybe you missed that. So let's run that. Boom. So it took like 20 milliseconds this time. So we're talking like in a couple of milliseconds now just to start up this Quarkus application. And it works exactly the same. So because we consider that when you're running native, it's like for production, so you don't have the development console anymore. But if you come over here to localhost, and I believe that I changed that to 8080 numbers generate. So yes, now you remember that my latest change was to have a low Bulgarian jug, but I'm refreshing, so I don't see anything new. But yes, I mean, at least I'm getting some requests back. And of course, there are some limitations I've told you before. There is no development mode. So it kind of works like a black box. What's compiled, that's what's over there. And if I can probably do a top, but if I go here to the monitor, maybe it's like a little bit easier to see. So if I search for number API, the runner, and if I increase this maybe a little bit more, now you see that I have a process that's running number API, and it's only 14 meg in memory, and that's only that REST endpoint, which is completely crazy, right? Now you might be asking, well, I mean, this native mode, it's really, really awesome, really, really cool, like less memory, less runtime, or less startup time, so should I use it all the time? Well, of course, like everything, you have to measure. Now, the idea is the native image, because of his nature, it's still going to have some other limitations, right? So it's not going to be, it's not going to be the peak performance of a regular JVM, right? Because there is no JIT compiler, there is no profiling that's going to optimize stuff depending on what's happening on the JVM, right? So you're missing a lot of that. Now, our recommendation is, let's just say that you want to have really big applications with really high throughput. You still want to go with the regular JVM. But if you have things that you want to have like function as a service or serverless, the native image is really the way to go. So I think the use case is going to dictate on how do you want to use both JVM or native. Our recommendation is really do a couple of performance checks on both, and see what's best for you. Okay, so that's pretty cool. Now, for Spring users, I was a Spring user in the past. I love Spring. I think that it is a great ecosystem, and they have done a terrific work over there. So I can completely understand that people are used to Spring, and they don't even if the APIs that we ship are things from Jakarta or MicroProfile, they're not as much as popular as Spring is. So some people are probably only know Spring and they want to use that one. Well, you can use Spring APIs instead, right? So I don't have them by memory. So what I can do over here, I have he's on shelf, so it's just like a really trick over here. So let me on shelf, and let me show you the code. So now what I have is like a Spring resource, and let me re-import this on the browser on the IDE. And so maybe I think you're probably recognizing this, right? So you have this REST controller request mapping, so it tells you where the endpoint is running, and then you have the GET mapping, and that's where you implement your GET for that REST endpoint. Well, I mean, for every or for and as you look into this is a Spring application or Spring code. Now, what I'm going to do over here is I'm going to run this again in Quarkus Dev, and if I go to my browser, so let's go to the console, 8080, I believe. Well, now you notice that I have a greeting API over here that was not there before, and even if I go to Swagger UI, it's over there /greeting. Interesting. So let's call greeting. Well, I have an hello over there. Okay, so now you see that I have the Spring API, or using the REST API from Spring, and I have the REST endpoint working in Quarkus. The interesting thing is the other one is also working. So even though it's using the other API, so you can even mix both. Now the even coolest thing is you can go and say hello, Bulgarian jug, and do a reload. Well, now you have hot reloading Spring code directly into Quarkus, right? My final take on this is, well, of course we don't support the entire Spring ecosystem. We started with REST, and we have a couple of other things, but the idea here is we give you just enough for you to start coding a Quarkus application using the Spring APIs, so you don't have to start and relearn or learn new things if you're lazy like me. So you want to do some REST endpoints using the Spring annotations? Yeah, go ahead and use them with Quarkus, and you have all the reload for free as well. So that's quite interesting. Ivan, are you there with me?
Yes, I'm here, but unfortunately you can't hear me.
Oh, I can now.
wondering why. So yeah, there are some questions waiting for you to hear me.
Please go ahead.
Okay, so if we go back to the test topic,
Yes.
Not the continuous tests. For continuous tests, I have another topic, but for the normal tests.
Yes.
So the question is from Stefan: is there a shared data between the Quarkus tests? For example, Spring shares the application context.
Yes. So what happens is, of course, Quarkus will if you can have like multiple tests, and Quarkus will share everything like that as well. So it's only like a per test class, Quarkus will only start like an instance of Quarkus, right? So it's not going to be like a separate instance per method test. So you're going to have like one big Quarkus instance, and all the tests are going to be executed over there. So of course, if you have some cache, some metadata that's been changing, then of course we either have to clear it up between tests, or you have to figure out something else.
Okay, thanks. And another question from Seraphim is that it's for the 2.0 feature for the continuous continuous testing. So if you have a test class that has an order of tests, so order test, order 0, order 1, order 2, order 3.
Yeah.
What would happen if you change something? Will all the tests be run in the class, or just one of them? Have you tried this?
That's a very good question. I actually don't know how the behavior is when you have annotations for ordering. I'll need to check that out. I'm not completely sure if we support that case yet. What we do support is, so Quarkus is able to figure out the because we do all of that analysis on the code, right? When we want to remove code to doing the building and whatever. So we do know how code is interconnected, so we know which test to run, right? But I'm not completely sure what happens when you have like dependencies between the tests themselves. So maybe it was not me that implemented that feature, and actually I'm not using dependency between tests, or I usually never use them. So I'm not completely sure what happens in that case. So I'll have to I'm gonna have to try it and come back to you later on that one. Sorry about that.
Yeah, we can try it by ourselves as well. Thanks. And a question from Mikhail. So he asks whether it's just only Spring REST implemented, or there are some more Spring things, and maybe I can answer that. I went to the code.quarkus.io and wrote in the pick your extensions, wrote Spring, and it came Spring Boot property, Spring Cache API, Spring Cloud Config, Spring Dependency Injection API, Spring Data JPI, Spring Data REST, which is experimental, Spring Scheduler, Spring Security, Spring Web API.
Yeah, so I'm sharing the screen. Not sure if you guys are seeing. So I'm showing. So these are the extensions that we support for Spring right now. Again, there's just like a subset on the entire Spring ecosystem. I mean, which is huge. But I think that you're already able to do a lot of stuff with those, because I mean, we try to pick the ones that are most used over there. And again, I mean, if there is something that you're looking for Spring that we support, please let us know, and maybe we can put it on the pipeline, or if you're curious enough, maybe you can provide that integration to us, right?
Okay, so no more questions so far.
Yeah.
Do you have some more magic from Quarkus to show us?
I mean, I can show a lot of other things, right? So I try to show some on the architecture and the things that you can get as a developer. The extra things that I can show you is the API. So the additional APIs that you can use, right? So one API, and let me see. I'm pretty sure that I have it right here. Actually, let me I don't have it on this project, so let me open a new one right over here. So maybe you recognize this project because we used to work on this together. So let me try to. So actually migrate this project to Quarkus. I'm trying to put this in full screen, but not sure why it's not working. Okay, so it's okay now. So as you probably remember, I mentioned that we tried to come up with not only the extension that we do not only provides the code that does the magic for Quarkus, but then we also started to add additional functionality, right? So one of the things that is really popular and we like a lot is Quarkus Panache. So Quarkus Panache is something similar with Spring Data, and the way that it works. And I mean, I'm not going to go into fights over here on what's the best way to do it, but you can even do it on the entity level or at the repository level. So the way that the Quarkus Panache works is, so you have like an entity, let's just say like an auction over here. So an auction, well, I don't really have to explain what an auction is, so I'm not going to go into details over there. But then you can extend this Panache entity base, and now you can treat your entity as like a repository directly, and then you can implement the queries directly over here. So they can even be like named queries or whatever. Then in the end, what you will do is interesting things like this. So if I found this, let me try to find where I'm actually calling some queries on this one. So auction. So this is like a really interesting case, right? So you stream like an object, you like custom to actions, and then for each you just call action create, and this create is actually persisting the data, right? But if you look into like the Panache API, you'll see there is like find by ID optional. So I'm probably using like find by ID optional. Let me say, yeah, here you go. So there's like this entity called connected realm. So you can say like connected realm, like find by ID optional, and you pass in the ID. So it provides like like all of these convenience methods that you can use, so you can access the database, the underneath database, and of course you can implement your own stuff. So there's like a bunch of find things that you can pass in with queries and parameters, find alls, list. You can even, I believe we even have like stream support somewhere. Yeah, there you go. So you can even stream them directly from the database. So so those are a couple of examples of extensions that we wrote that add the additional functionality to the already existing ones, like Hibernate, right? So what I'm trying to say in the end is, just go start up like go on Code Quarkus. There's also the Quarkus Quick Starts. So if you go Quarkus Quick Starts on GitHub, you have this GitHub repository. I'll just increase a little bit, which has a lot of examples on a lot of stuff. So you'll see like using Amazon APIs, concept propagation, so Hibernate stuff. So you're having like the reactive questions. So we have like a lot of reactive examples with Hibernate, and Panache itself is also reactive. So you can combine it with Hibernate reactive. Kafka stuff, micrometer to do metrics. So a lot of security stuff. So also have support for all OAuth2 and JWT tokens. I mean, other than that, what I can say is like we give you Quarkus as a platform where the main idea is try to push everything for build time and try to optimize a lot of stuff. And then the extensions not only do that work, but then try to add like new APIs that everyone can benefit from. So I'm not. I have a lot of other bunch of things, but I'm not completely sure what you want to see. If there is anything specific, I can try to show it.
Yeah. So maybe.
But if not, we can.
Yeah. It took a lot of time so far.
Yeah. I'm not sure how much time we have left anyway.
No, we don't have a boundary, but I mean, everybody gets tired after some time.
Of course.
So I have one last question. What do I need to have on my computer, installed on my computer, so that I run that Kubernetes magic there that you run?
So on the Quarkus side, you don't really require anything, right? So Quarkus itself does all the generation for you. So in my particular case, what I do is just use the Docker client already comes with I think it's Minikube that you can turn on, which is like a Kubernetes local Kubernetes cluster that you can use for you to deploy stuff directly into a Kubernetes cluster. But you can definitely do the same of deploying to OpenShift, to Kubernetes on EC2, right? It's just like a matter of like changing the deployment address, and that's it.
Okay, so thanks a lot, Roberto. It was really interesting. I mean, especially the 2.0 stuff that are almost baked.
Yeah.
And yeah, thanks a lot. And good luck with JNation tomorrow, and good luck with Portugal tonight.
Yeah, I mean, thank you so much for having me. I hope that people find this session interesting. If not, let me know anyway, so I can know where to improve. And if maybe if you don't have any questions now, but you have them later, feel free to reach me out on Twitter, email, Zulip, whatever. So I'm Rad Cortez on every place. So feel free to search me out on that name, and send me any question, and I'll be happy to answer them.
Amazing session. Yeah, it was awesome. It was a pleasure listening to it.
Wonderful. Thank you so much.
It was yeah. Even I have a couple of friends who listened to the session that are not technically proficient, and they still liked it and listened to it.
Oh, cool. Thank you so much.
Yeah.
Okay, so thanks again, and yeah, wish everyone a great summer. This is going to be our last session before the summer break, and I hope that we'll have some great surprises for you in September. We are trying to prepare something with Naiden, but yeah, let's see. And until then, have fun and
okay. Bye-bye.
Bye-bye.
Bye.